Obtain the Fourier transform of x of e raised to power at into u of minus t. Plot its magnitude and phase spectrums. So the function given is like this. This is exponentially increasing, but unity function is minus u of minus t. So we have the function like this. So the function it is given x of t is equal to e raised to power at into u of minus t. So we have to find a Fourier transform. So equation for Fourier transform which transform the time domain function into the frequency domain. So x of omega is equal to minus infinity to infinity x of t into e raised to power minus j omega t into dt. So this is the equation for finding the Fourier transform. Now we have to put this x of t value here. So x of omega is equal to x of t is e raised to power at into u of minus t into e raised to power minus j omega t into dt. Okay, now see the limit we have to change here, minus infinity to infinity. Your function is exponential rising only on this side, left half of the s plane. So our limit change will be from minus infinity to 0. So it is minus infinity to 0. Now we have to find the integration of this minus infinity to 0 and this e raised to power a minus j omega and t, and u of minus t is it is function 1, so we can substitute here 1 into d of them. Okay, so next is what is the integration of this 1 over a minus j omega into e raised to power a minus j omega t, and the limit is minus infinity to 0 in this way. So e raised to power 0 is 1 and e raised to power infinity, if you put here infinity it will be 0. So what we are getting here, we are getting here 1 minus 0, it is 1. So we are getting here 1 over a minus j omega. So we have got this value. Now we have to find the magnitude of this x of omega. So what is the magnitude? Magnitude of x of omega is equal to 1 over a square plus omega square, and the angle of this x of omega is equal to minus tan inverse omega by 8. Okay, so we have like this. Now we have to find the magnitude and phase plot. So here omega is equal to, we have to substitute different values and we have to find the magnitude of x of omega. Now on this side it is a frequency versus angle of x of omega. Okay. So when frequency is 0, what will be the, if you put here 0, what we will get? We will get 1 over a. And when it is a minus infinity, what will be the magnitude? It is a 0 if you substitute there. And when again it is a infinity, magnitude will be 0. So again you can find the different angles here, different frequency for different, will get different angles. So when omega is equal to 0, we will get here angle 0. When omega is equal to infinity, it is a pi by 2, and when omega is equal to minus infinity, it is a minus pi by 2. So we have got this, and from this we have to calculate now phase and magnitude plot. So this is the magnitude of x of j, x of omega versus the frequency. On this side it is a minus infinity, on this side it is infinity. So when frequency is your 0, the magnitude is 1 over a, and when it is a minus infinity, it is we are getting like this. And for omega is equal to infinity on this side, we are getting 0, so the magnitude will like this. So this is a magnitude plot. And now the phase plot, we have to draw the phase plot from this. So this is 0, this is angle x of omega, this is the frequency, on this side it is minus infinity, infinity. So when, so this is suppose pi by 2, this is minus pi by 2, this is pi by 2 line, this is my minus pi by 2 line. So now when frequency is 0, what is the angle? Angle is also 0. When frequency is infinite, angle is like this. So at infinite it is touching the pi by 2 line, and when it is a minus infinity, it is touching at minus infinity to minus pi by 2 line. So this is the phase plot. So in this way we can find the Fourier transform of x of t is equal to e raised to power at into e of minus t. Thank you very much for watching this video.